also has a finite area that it can see. It is subject to the very same laws of perspective that our eyes are. Just because it has better light gathering capabilities and it has higher magnification does not mean that that it will be able to see infinitely off into the plane.
I didn't say it could see infinitely. What I'm saying is that you guys have to believe that you can see all the stars. But that is not.
We believe what we see.
Hold on a second.
No, we're telling you what we believe, and it works.
No, you cannot see the southern constellations and the northern constellations at the same time.
That's what we're saying.
Is a fact.
We don't see that.
I can call somebody up in Argentina right now.
Nobody's saying that, though. You're asking us how come we don't, and we're telling you because we don't. That's what we see is what we get. When I'm in the north, I see the northern stars. Because I'm not quite at the North Pole, I can see some of the southern stars. I'll never see the Crux. I'll never see Octanus. I'll never see those from where I'm at. But I do see past the center. So it's like, I don't know what you're saying. You're asking me
because
why don't I see all the way across?
The reason is because you have no obstructions in order for you not to see octans.
I have that's what we're saying.
You're assuming
because I don't see it. So what I'm saying is our perspective runs out. The sky, have you ever seen, Robert, when you're at the beach or anywhere, the horizon line, which is at your eye level, the sky appears to come down and meet that horizon level, correct? The sky does not go on a flat plane as far as your eye can see, and then the water runs out at your horizon level, and there's like an air pocket between the sky and the water. The sky shoots down like a triangle and meets your perspective, which is not far at all.
But that's a different issue. That's a different issue.
What,
your model requires that all the stars be seen because you have no way to explain why they can't be seen.
No,
I just told
Robert,
you.
let me explain something to you. If that was true, Robert, then I would be able to take my telescope, my Meade 10-inch telescope, and go up to one of the highest peaks in Colorado and look east, and I should be able to see Kansas. The fact is, I can't, and Kansas is only a few hundred miles east of where I am in Colorado. And the reason that I can't is because the telescope is subject to the same laws of perspective as my eyes are. Think of it as looking down a pyramid. If you picked up a pyramid and you held the large end to your eyes and then looked down it, and you will see how that pyramid shrinks and gets smaller and smaller and smaller as it gets to the top. All laws of perspective have to obey that, whether they are magnified through a telescope or not. And that is the very reason also why we're saying that you cannot see thousands of light years to distant stars, because we still have those same laws of perspective in effect. And that's the thing that does not make any sense, because you're breaking all laws of perspective. Whether you want to say that this is something applicable to standing on a flat Earth and supposedly being able to see all the stars in the south, or whether you're saying that you can see all the way to Cygnus Octanus or whatever it was. The laws of perspective simply do not allow that to happen. And
I don't know. You keep saying laws of perspective. I don't know what you're talking about. Okay, I know what perspective is, but I don't see how that's going to disprove what I've just said to you.
Have you seen a boat supposedly go over the curve, as anybody who thinks that the Earth is round would say? You've seen that, right?
Yes. Okay. And if you get a telescope and you focus on the boat, you can actually see the boat again.
Okay, so that right there kind of helps prove the flat Earth more, but if you kept watching that boat, eventually it's going to get small again, and again it's going to fuzz out and go supposedly over the edge. That's just your perspective running out, and that's not very far. Figure with your eyes, you might see that 5, 6, 7, 8 miles out.
Yeah, but see, listen, you can't use the flat Earth to prove a flat Earth.
I'm not. I'm telling you that the Earth that we live on, go to the beach tomorrow, watch a boat go out, tell them to relay back to you their distance. At 10 miles, you're going to lose it. Then you're going to get a telescope, and at 25 miles, you're going to lose it. At that point, that's where your perspective ends, at 25 miles. Yet, now you're expecting me just to look a little bit higher and see 8,000 miles across? That's not what we see every day.
If we put the Hubble Space Telescope in the tent and looked at that star that's 8,000 miles away, we will be able to see it, guaranteed.
But here's the thing: you're saying that, but you're just assuming that this Hubble telescope can see 8,000 miles when there's no evidence of anything on Earth that you can see anywhere near that far. In fact, when you're in it,
gentlemen, then we've reached an impasse, okay? Because the Hubble Space Telescope has taken pictures of the universe. It has seen galaxies out there by the tens of millions, okay? Those pictures cannot be made up.
they are.
Oh, but they can and they are.
They are.
No, they are not made up. I know amateur astronomers who have very powerful telescopes. I've looked through them, okay? I can see out there. I've seen it with my own eyes.
Robert, so
All right?
have I.
You guys,
So have I, and I know exactly
we're
what
not
you're
talking
saying.
about a telescope you buy from the 5 and dime store. We're
Neither-
talking about very powerful telescopes that can see many, many, many miles out there, okay?
Yes,
That's what we're talking about.
we are talking about that.
It has
And
nothing to do with perspective. I should be
No.
able to see all those stars at night if I have a very powerful telescope. That is a fact.
Then why
It has-
can't you see across from? Okay, I guess he's just you would
it
just.
has to do
I'm
it has
talking
to
about
do
here.
with light gathering and magnification. I don't have a 5 and dime. I mean, I have a fairly substantial telescope. It's a Meade 10-inch. And granted, no, it's not a NASA telescope, but you know what I'm saying is that I see this stuff too. But what we are saying that we're actually seeing, what we're looking at, is the ceiling, if you will. It is the stars within the firmament, the lights,
As
the
I
lights
said,
in the
Bob, you
sky.
can't use the flat Earth to prove the flat Earth. Okay?
We're not.
You have to get at this from a different angle, because you can't say to me, well, Robert, it's because we have a dome and the stars are inside the dome. That's why you're not going to be able to do this or that. You can't do that. Okay? You have to prove it by the
Okay.
scientific data.
Then let's look at. All right, let's build a preponderance of evidence here. Then, there's been many flat earthers that have done experiments. Say, for example, on the curvature of the Earth. Okay, Jaron himself has gone out and done. We've done the calculations. The math dictates that there should be so much curve that would obstruct our vision, and every single experiment that's ever been done around that has proven that there is no curvature. Furthermore, if you take and you look at some of the footage, like from the world's record space jump, when you look at the NASA cam outside of the capsule, you see that they're using a fisheye lens, which gives a false curvature of the Earth. Now, first of all, your perspective would never see that because that isn't what you would see on a sphere. But my point is before he gets out, you see very clearly a flat plane at supposedly 100 and some odd thousand feet above the Earth. When you look at the footage taken from weather balloons that have been launched in flat Earth experiments, or rockets that have been launched in flat Earth experiments, we see no curvature. So again, we're building a preponderance of evidence not only by empirical evidence, but by measured and calculated evidence. So we're not just saying that, we're just saying, oh no, you can't, we're just pulling this out of our rear end, so to speak. I mean, this is actually empirical evidence that we are relying upon, not only from ourselves, but from other agencies like NASA and many other sources.
And I would just,
let me analyze this for a second here.
Okay.
Okay. First of all, when I was preparing for this tonight, I saw a video by a gentleman who said that when he did his laser test, he calls it the 20-mile laser test, he found out that the Earth has to be concave, not convex. And he has all kinds of diagrams up there showing you why the Earth has to be this way. In other words, we're on the inside of the ball instead of on the outside of the ball, according to the way he sees things. And it looks very convincing if you look at it and you don't know anything else. Okay, so that's one issue. The other issue is when I looked at Jaron's 4-mile test, it didn't prove anything. Because first of all, 4 miles is not going to give you any kind of verifiable evidence that we have a flat Earth, because the terrain can dip, the terrain can go down.
Over water?
Not over water, it can't.
That's sea level.
Water always seeks its own level.
Right, but the problem you have there is, how do you know that your laser beam is going to be lateral to the surface of the Earth? You
No,
have
no,
nothing to
I turned
measure
the
it
laser-
against.
I turned the laser to the board, and then the camera picked up the laser from 4 miles across.
You have to watch the whole video.
We didn't end up doing, because when I shot the laser across, the beam refracted. It was too diverged. It was too wide.
Yes.
Right. So then we did, instead, having the camera zoom across the water, and could it pick up the laser light at 4 miles across?
Well,
And it
that's a
could,
flaw.
because-
That's a flawed experiment
Oh,
because
and
the laser light you yourself admitted was 10 feet wide by the time it gets to the
no,
camera.
hold on. What I'm saying is, we were on one side of the water. We tried to shoot the laser across the 4 mile distance, but when it got to the other side, the beam itself was like 10 feet wide. So we scratched that experiment, said that's not going to work. But then we thought, what if we go to the other side, shine the laser just 6 inches off a white board or off a board, and if the camera from the other side where we were before could zoom in and see that light, it should be behind the curvature of the Earth. The curve is 10 feet. So technically, I should
because
have
when the light bounces off the board, it's going to expand as it goes out, and that's what the camera's going to pick up.
The camera picks up a single point of light, not a diverged beam.
Right, you're saying that
It's
it
going to pick
reflected
up
over
light
the
that comes-
curvature?
It's going to pick up the light that comes within that 10 feet radius.
Okay, what about
Not
no,
as a
no,
pinpoint
you're not-
beam. It's not going to, Robert. It's going,
Yeah, the
we're
beam
seeing
was
it as a
completely-
pinpoint beam, not a diverged beam.
Right, I
Well,
went to the other side.
Wait a minute. When you shot it from one side to the other side, you said it widened by 10 feet by the time it got to the other side.
And that's why it was scrapped.
Right, we scratched that.
different days?
Yeah,
So
I
then-
know, but you still used the same laser beam, didn't you?
But we went to the other side and shined it at that side, a matter of 6 inches. So the
Right.
beam was a tiny little,
It was a
2
laser.
centimeter dot.
In other words, what we did, Robert, is instead of trying to send the laser beam to the optics, we used the zoom on the camera and took the optics to the laser beam. That eliminates all possibility of beam divergence, and what was recorded was a single point of high intensity light, not a diverged beam. That's what we're trying to say.
And I'll give you that 4 miles to us is not what, ideally, but we already
Well,
know that the further we go out.
What you'd have to do, Bob, is prove that when you pointed the laser at the board and it reflected off the board, that it went out as a single beam laser that did not widen as it went out. Can you prove that?
Yeah, yes, actually
Yeah,
we
we
can,
can.
because of the way he did it. He shined it inside of a black box that would have constricted any reflection like that. Not only that, as I said, we took the optics to the box by zooming in from the camera. In other words, it could have been a lighter. It doesn't matter. It could have been a lighter.
Yeah, I know, but the camera's not going to. The camera. What is the camera taking a picture of? The beam that reaches the camera, or the light that's reflected off
No,
the board?
you'd have to watch the video again, because when we were on the other side, we had cameras on both sides, so you can see me pointing the laser, hitting the board, and dying. It wasn't reflecting.
Now wait a minute. Answer my question.
Okay.
You take a picture of the laser reflecting off the board.
It didn't reflect. That's what I'm saying.
It's a video.
You see the point of light on the whiteboard. You'd have
Okay,
to-
but in order for the camera to take a picture of it, it has to reflect to the camera.
Okay, we didn't
correct.
camera-
They took a picture of the light on the whiteboard.
Yeah, I
Right.
know, but the light beam has to go to the camera. The camera doesn't go to the light beam.
What do you mean it doesn't go to the
Zoomed
light?
in.
That's the whole idea behind the zoom.
It's taking a picture of the light that is received at the camera lens.
Okay.
Yes.
Okay.
Okay,
And
so
we've
how do you know
extended
that light did not widen when it reached the camera?
You're saying that it would have had to gone up and over the curvature, and this is the same thing we hear from, and I know
No, I'm not saying that. I am saying that when it reflects off the board and reaches the camera on the other side, it's
So
still
how did it
going to
get there?
widen, just like it did when you did
No,
the
no, no,
first
no.
experiment.
Totally different.
No. When I shine the laser, you've ever played with your cat with a laser? It stays a little point as you run around your room. It's a
If there's something strange in your neighborhood, who you gonna call?